Hello, engineers or the future engineers. Welcome to the lecture series on control systems. And you might have clicked the video just because you want to learn something new from me, or just by mistake. Anyways, I'll welcome you all to the channel, and let's start with the control system. So, the goal of this lecture series is not to solve so many mathematical problems or something. I will be focusing more on the topics which are difficult to grasp or difficult to visualize. So I will be focusing more on the qualitative aspect of the problems. Like as engineers, what we want to solve some problems, the practical problems, not some mathematical big, humongous equations and all. So to solve some practical problems, we want to appreciate the problem first, to understand the problem fully, then we will be proceeding with our steps. So that's why I would be more focusing on the qualitative aspect of the problem, not the quantitative aspect. Yes, definitely I will be doing some mathematical calculations, but not that rigorous that you find in the regular classroom studies or in the books. But I must say, like everybody has their own style of reading and learning something new. So whatever suits you, I'll be commenting down few good lecture series and books. So before starting the lecture series or diving into the beautiful world of control system, I would like to introduce myself. I am Pratik, uh, Pratik Priyaranjan Pradhan. I'm a second year PhD student at Aerospace Department, IIT Kanpur. So basically, my aim is to familiarize you with the control system terminologies and hands-on experience on MATLAB. So this course will be through this course I can guarantee if you even if you don't know anything about MATLAB, you will be able to solve few problems on MATLAB or write down few scripts. So I'll be extensively taking the MATLAB tutorials. Okay, so let's address the elephant in the room. Like, what is control system? What is control system theory? So, let's assume with a simple example. Like, the term self control system is self-explanatory. Like, you want to control something. Like, what happens when you want to control something? Just let's take a random example. Like, if you want to control your weight, like the mass of your system to be particular. So, so if you want your weight to be around 65 kgs, and so you have the reference like this is my target 65 kgs, and but you have now currently you have something else like suppose 75 kg or something. So you want your weight to be 65 kg. So what you will do, you will reduce your diet, uh, and maybe exercise something like workout. And suppose you are at currently at 55. So maybe you will be increasing your diet and do something like that so that you will be reaching to 65 kgs. So this is a very simple example of control system. Like you have one reference, this 65 kg, which is your target. It's called target or desired or reference, and you have some actual output, actual data. This is the actual data what you have. So how this concept be useful to us in our engineering? So I must say, like control system is not a specific branch or not a specific engineering department. It's like a tool, just like maths. So like maths, you can apply it to different kind of fields of engineering, like the ordinary differential equation or different maths. You just apply the tool. Just like that, control system glues all the departments, I would say. Just like if you are from electrical engineering background, then there are some switches and some buck boost converters there, and like to like increase the duty cycle and all, buck boost converters, you need the control system. If you are from electronics and communication background, then maybe you have some antenna. Sorry, pardon me. I will be drawing something, and I know I am poor at drawing. So this is the antenna. If you have some antenna and you want to track something, like something in the sky, the uh, just imagine some drone or something, and you want to track it, or you want to send the data to that drone. Uh, okay, so to that drone, so you need the tracking system, then the electronics, and in mechanical department as well. In mechanical department, you need, if you have some system and you have to analyze the vibration vibration and you need the vibration to die out as fast as possible, then control system is your way. And in robotics also, if you want to track a path, which will track a path or some other kind of steps, then you need the control system. And in aerospace engineering, like all the flight dynamics and all flight stability, like if you have some this kind of plane, then here you have the ailerons, and the the rudder, everything, like you need to control the flight, so there is also useful. So basically, control system is a field which can be applied in anywhere, like in even biotech and biomedical, uh, medical. Nowadays, the artificial pancreas techniques are also going, where you have some artificial pancreas and you need to maintain the glucose level. So there you have to introduce the control system aspects and the control system theories to that. So I would say, like, control system is not a specific field related concept. It's a mathematical tool which can be applied to any field of engineering. So what will be my syllabus? Like I would be teaching, like as I have already mentioned, like I would not be going deep mathematically deep into the topics. I'll just introduce and get the qualitative aspect, like some might be some figures or some animation. I will try, and MATLAB. So first I would like to do some closed loop. I'll teach these things: closed loop versus open loop. Don't worry if the terms are alien to you. I'll be explaining them. And then some stability related concepts, then time domain and frequency domain analysis, and more, like why we need time domain and why we need frequency domain. Like if you are in a college or you have learned the control system, you know the formula, you might be knowing the formula, you have so many books to get the formula, but why we need it? Like there I will be explaining about the laplace laplace and fourier, Fourier. So these are very beautiful concepts. Actually, if you get the feel of it, na, you will never forget the concept. It's that exciting. And apart from these topics, the like root locus, Bode plot, Bode plot, and like my personal favorite, Nyquist stability. So these are the sorry, stability. These are the topics I would cover. Apart from this, all the things related to MATLAB. So this will be the overall syllabus. I'm not going in a particular order. Sometimes I will be explaining some mathematical background as well, like mathematical uh, background, like on signals systems, systems, like those things. So I will be explaining the basics of signals and systems and the different types of input signal in the next lecture series. Like the first, I will be revising those concepts. So see you in the next series. Thank you.